I can't see it on the screen. Okay. Hello everyone. Welcome to Tutoratti, and I am Vibhuti Joshi, and I will be discussing with you all the chemistry paper which we all had today. Let's reduce our stress by looking at the solutions of what came in the exam today. So, let's start with the question paper, everyone, starting with the first section of the question paper. Now, as we all know that the first section of the question paper, it contains MCQs, right? So, let us look at the first MCQ, the 4 options, and see what the answers will be. Starting with the very first one. The first question says, the coordination number of atoms in body-centered cubic structure, also called as BCC, is. So, let us figure it out. See, when you look at the question, it says body-centered cubic structure. So, this is your BCC cell. Now, what is a BCC cell? A BCC cell, if you remember, is a cubic cell, right? Now, when I say body-centered cubic unit cell, let us find out where are the atoms present in this kind of a cell. The atoms in this kind of structure, they are present at the corners, obviously, that's your basic unit cell. And since we have 8 corners, so 8 atoms are occupying the corners of a cube. Now, the name is BCC, body centered, which means one atom is present within the body. So, one atom is present right over here within the body of the cell, and this is called as BCC structure. Now, the question is coordination number. What is coordination number? Coordination number is the number of atoms surrounding a particular atom. So, if I have to figure out the coordination number of this atom which is present at the center of the body, then let us see how many atoms are surrounding it. 1, 2, 3, 4, 5, 6, 7 and 8. Because there are 8 corners and the atom which is present at the center of the body, it is surrounded by all these 8 atoms present at the vertices of the cube. Therefore, I can say that the coordination number of BCC is going to be 8. That is our first question. Moving on to the second one. I hope the first one is very much clear to all of you. The second question is, in calculating osmotic pressure, the concentration of solute is expressed in. Now, if I have to express the concentration of a solute, if you remember, osmotic pressure is equal to CRT. What is C? Concentration. If I have to furthermore write the formula, I can make it N upon VRT. And this N upon V is nothing but molarity. So, that is question number 2 of our section A MCQs, and the answer will be A, molarity. Moving on to the third question, students. Very, very simple. The question is the enthalpy change for a chemical reaction in which, if you see H2O from the solid state is converted into the liquid state. The answer is simple, it's vaporization. It's a factual question. Let's move on to MCQ number . Okay, just give me 1 minute. Fine. Let's move on to the next question. The next question is question number 4, which says, which of the following transition element shows maximum oxidation state? Now, what is oxidation state? Oxidation state is the number of electrons that an atom can lose and gain a charge. So, if I talk about the oxidation state of, let's say, scandium, manganese, Fe and vanadium, then I first need to write their electronic configurations to get the right answers. So, let's start with the electronic configurations of all of these, starting with the very first one, students, which is scandium. Now, what is the atomic number of scandium? The atomic number of scandium, as we all know, is 21. So, if I write 21 here, the configuration, as you remember, can be written as AR 3D1 4s2, correct? Now, let's figure out the number of electrons that scandium can lose. See, if I make the orbital representation of this, there is 3D, which is having 5 orbitals, right? And in this, we have only 1 electron because the configuration says it's 3d1. And then we have 4s2, which we all can see is the last shell or the valence shell. And obviously the electron will be lost from the valence shell, which means 2 electrons will go away from here, giving scandium the oxidation state of +2. And always the unpaired electron from the d orbitals are also lost, which makes it 1 more. So add 2 to 1, which makes it +3. So the possible oxidation state of scandium will be +2 and +3. Okay. Moving on to the next one, which is Fe, students. When I talk about Fe, the atomic number of Fe is 26. So the configuration will be Ar, 3d6 and 4s2. Again the same concept. Just find out the number of unpaired electrons in the d orbital, and obviously the electron from the 4s orbital will have to go because it belongs to the valence shell. So if I calculate the total number of electrons which Fe can lose, it will be 2 electrons will go from 4s, giving it an oxidation state of +2. And the unpaired electrons from d orbital, since I have got 3d6, how do we fill the orbitals? First we will fill 1 electron in each, and then the pairing will start. That's what the rule of electronic configuration tells us about. So it's 3d6, 1, 2, 3, 4, 5 and 6. Let's figure out the oxidation numbers. 2 already went from here, so +2, this will make it +3. Then this is good, the another one is going to make it +4, then +5 and +6. So the oxidation state will be +2, +3, +4, +5 and +6. These are the possible oxidation states of Fe. Moving on to the oxidation state of Mn, again based upon the electronic configuration. The configuration will be Ar, 3d7, 4s2. So let's again find out the unpaired electrons. 2 will go from here, so it's +2. And the unpaired electrons from Mn, which is 1, 2, 3, 4, 5. So it becomes +3, +4, +5, +6 and +7. That means in case of Mn, the possible oxidation states are +6 and +7. It is actually 3d5, +7 was the oxidation state. So it becomes +7, and if we talk about vanadium, the atomic number is 23, giving it the electronic configuration of Ar, 3d3, 4s2. Again 2 electrons will go from here, so +2, and 3 unpaired electron will make it +3, +4 and +5. So now if you check out the oxidation state, the maximum number of oxidation state, as you can see on the screen, is shown by Mn, which reaches till +7. So your answer for question number 4 will be option C, which is Mn having oxidation state right from +2 to +7. Alright, moving ahead, let's take the next question, question number 5, students, which is from the chapter Coordination Compounds. The question says, the correct formula for the complex compound sodium hexacyanoferrate 3 is. Now let's quickly check out the formula with the help of this name given, hexacyano, right? It means there will be 6 CN atoms, 6 CN ions, sorry. So here are 6, here there is 6, here there is 6, and this is also 6. So all of them, they have 6 CN. So that is not the differentiating factor clearly. Now let's move on to the next one. Ferrate, they all have Fe. So again, that also cannot be considered while checking out the answers. Now the most important thing in the question is this 3, which is the oxidation state of Fe. So if you figure out the oxidation state of Fe in all the 4 compounds, you'll be able to get your right answer, right? So let's start with the first compound and figure out the oxidation state. See, the charge on Na, as we all know, is +1, which gives an overall charge of -1 here, right? So if I have to find the charge on Fe, let us consider this as X, plus the charge on Cn is -1 each. There are 6 Cn. So it will become X plus -6 is equals to -1, giving me the answer of +5. But do I have +5 in the question? No, my answer should be +3. So this is the wrong option. Alright, moving on to the second option now. Na2 FeCN6. Again, if you think about this, this is Xe, this will be -6, this is +2, so overall will be -2 here, and your X will come out to be +4. Simple math. Moving on to the third option, students, it's Na3. So this will be +3, this will be X plus -6, overall will be -3, giving you the value of X to be +3, and that is what I wanted. So the answer for fifth question will be option C. I hope this is clear to all of you. We are done with 5 MCQs. Let's move on to the sixth question, everyone. Talking about the sixth question, students. The sixth question says isopropyl benzene on air oxidation followed by decomposition by dilute acid gives what? Right, so let us first try and figure out this. Isopropyl benzene. Let me make it here. This is your benzene. Let's make it isopropyl. So I'm putting the CH3 group here. Now it says on air oxidation. That means oxidation, addition of oxygen, right? So I'm going to add oxygen here. The moment I add oxygen here, it is going to connect with this CH and it will convert this into a compound having CH3, and here I will have OOH because oxidation has taken place, right? Now after this they are saying further there will be decomposition by dilute acid. So now let us bring acid into picture. Here comes your acid. When an acid comes, what I'll get is I'll get the benzene ring having OH group, which also is called as phenol, having the formula C6H5OH. That's your correct answer. And with that you are going to get the byproduct CH3COCH3. So that is question number 6, everyone. We are done with 6 MCQs from your section A. I hope this much is clear and I hope you did it right. Let's move ahead with the next question. Okay, moving on to question number 7th now. 7th question says the name of metal nanoparticle which acts as highly effective bacterial disinfectant in water purification process. Again a factual question, the answer is silver here. So the answer to this will be silver. Let's mark the right answer. Moving ahead. Next question number 7th. Acid anhydride on reaction with primary amines is going to give you amide. Again a factual question. Let's move on to question number 9th now. Alright. 9th question says the standard potential of the cell in the following reaction is, it looks very complex but it's very simple. Like if you remember the concept, it's very simple. I will simply write the electrode potential of copper minus of electrode potential of cadmium. So that is going to give me 0.334 minus of 0.403, which will give me addition of these two, and my answer will be 0.737 volts. I hope this is clear to all of you. Now let's move on to question number 10th. The value of H plus ion concentration in moles per liter of 0.001 molar acetic acid solution, and they have given you the acid dissociation constant, which is Ka. So if I have to figure out the value, it will be, if you remember the formula, it is going to be under root of KaC, right? You simply have to calculate this, the value of K is given to you, and your answer will be option D. So these are the 10 MCQs that were given to you. I hope this is clear. Moving on to the next question. We are done with the MCQs here. So now we are going to switch over to the next part. The next part, student, is a theoretical question. So let's start with the first question. Write the product formed when alkyl halide reacts with silver nitride. Okay, so when I say alkyl halide, let us like in general write this as Rx. So this is going to be my Rx, and they are saying it is going to react with silver nitride, which is AgNO3. So if I write over here AgNO3, students, now there is a trick, which is, they said write the product formed, right? So there are two possibilities now. If you remember the SN1 mechanism and the SN2 mechanism. If you are doing the SN1 mechanism, your product form will be RONO2, like this. And if you are taking the next mechanism, then it is going to be RNO2. So these are the two possible products depending upon the type of reaction that we are taking. It could be SN1 reaction, it could be SN2 reaction. Alright? Fine, let's move on to the next one. The next one is write the name of product formed with when acetone is treated with 2,4-dinitrophenyl hydrazine. So first of all, we need to know what this is. Let us try and write the reaction. When I say acetone, the reaction could be written like this. Let us make this 2,4-dinitrophenyl hydrazine. So here is your benzene ring. Alright, 2,4. So this is 2,4-dinitro hydrazine. Perfect. Then it is treated with, when are they treated? When both of them they are reacting, what are we going to get? So let us figure out the answer to this. The answer is DNP. 2,4-dinitrophenyl hydrazone. If you remember, the structure would be something like this. Here is your benzene ring, NO2 group is still there, here also. In this position, I am going to get NH, N, and this is your compound, which is DNP, and that is our question number 2 of section A, question 2. Let's start with the next one. Very simple, the next one is, which is write the name of biodegradable polyamide copolymer. Very simple, nylon 2, nylon 6. That was the answer of question number 3. Let's move on to question number 4. The fourth question says identify the molecularity. What is molecularity? It is the number of molecules that are actually combining to give you the products, right? So write the molecularity of following elementary reactions. Look at the reaction. It's NO2, O3, NO3 and O. So now if I talk about the molecularity, it is nothing but the stoichiometric coefficient. Here there is one molecule, here there is one molecule. So the answer of molecularity in this question is going to be 2. So that's our question, students. Question number 4 from the second part. Let's move ahead. I hope till here you all did it right. Moving ahead to the next question. Okay. The next question, everyone on the screen, please. Question number 5. Question number 5 says, what is the action of selenium on magnesium metal? Simple question from the chapter P block elements. If you look at the question, it's very simple. Selenium and magnesium, Mg plus Se definitely will give you MgSe, which is nothing but magnesium selenide, right? So again, it's one easy question. Moving on to the 6th question now. Chapter coordination compounds. It clearly says write the name of isomerism in the following complex. If you see in this particular kind of the coordination complex where the positive charge, that means your cationic part as well as your anionic part, they are both in the form of a coordination compound, right? So since they are both in the form of the coordination compound, this is going to represent coordination isomerism. We had 4 types of isomerism, right? And the isomerism wherein both the cationic as well as the anionic part are made up of complex compounds, that particular compound is going to have coordination isomerism. So therefore, the answer for this is going to be coordination isomerism. Alright. Moving on to question number 7th, everyone. Question 7 says, write the name of alloy used in Fischer-Tropsch process in the synthesis of gasoline. And the answer to this will be cobalt thorium alloy, COTH alloy. The answer to this will be COTH alloy. Fine. Alright, let's move on to question number 8. Atharva, I'll get back to you, don't worry. But let's first look at question number 8, please. Question number 8 says, Henry's law constant of CH3Br is this much. The constant is given to you. And what is the solubility? They are asking you for solubility. If you remember, solubility is equals to KHP. Just put the value of this, multiply them and get the answer, which is going to be 0.026. So the answer will be 0.026. That's your final answer for question number 8. Alright, just look at the answers and I will get back to the question that you people asked me. For third question, the answer will be vaporization, which is option A. Alright, so I think this much is done. Let's move ahead. And I hope you all are getting the right answers. If not, please don't panic. We have a lot more to do. Let's start with section B, students, starting with the first question. Simple, isn't it? Explain pseudo first order reaction with a suitable example. Very, very simple, I guess. When I say pseudo first order reaction, what are those reactions? These reactions are those which are looking like a first order reaction but are actually second order reaction, right? So such reactions are called as pseudo first order reaction. I hope you must have written the right definition as well. So what is pseudo first order reaction? The reactions which looks like first order but they are actually second order reaction. They are called as pseudo first order reaction. And then you can have n number of examples when it comes to pseudo first order reaction. Like if I talk about acid catalyzed hydrogen reactions, they will be a part of pseudo first order reaction. So this is our first question. Moving on to the next question, which actually is question number 4. It says that write the consequences of Schottky defect with reasons. Now what is Schottky defect? It is a defect in solid compounds wherein the number of cations and anions are missing. And the irony is that equal number of cations and anions are missing. And that defect is called as Schottky defect. Now what will happen if that kind of a defect is present in a given solid compound? The problem will be because of the absence or because of the missing of equal number of cations and anions, the mass overall will reduce, and because the mass decreases, definitely the density will also decrease, and that will result in changing of properties of solids. So that's your question number 4, a big paragraph on Schottky defect. Moving ahead. The next question is, what is the action of following on ethyl bromide? Right? So let's start with the ethyl bromide thing, students. Let's start with the first one, sodium and dry ether. What's reaction? So when you take ethyl bromide plus sodium, it is going to give you alkanes generally, and since here we have ethyl, so it is going to result in the formation of butane. Let's move on to the next one, magnesium and dry ether. When I say magnesium in dry ether, it is going to give me a very, very important reagent, which is also called as Grignard reagent, having the formula RMgX. Now because I have got ethyl here, so my formula will be ethyl, then Mg, and your X will be definitely bromide. So that is the product of your second part of question number 5. Let's move on to question number 6. Question number 6 says, explain the formation of peptide linkage in proteins with an example. First of all, when I say peptide linkage, how is this formed? So when I say a peptide linkage, it is actually made up of alpha amino acids, right? So let's actually take an alpha amino acid. So if I talk about a peptide linkage, it is having alpha amino acid. Here is your NH2 connected to CH. Since it's alpha amino, so this is my alpha carbon connected to COOH. Now there has to be a R group over here which will determine the examples further. Now what happens is, if I have to make a peptide linkage, what I'll do is I'll take another alpha amino acid, and the other alpha amino acid I'll place it in such a way that the COOH of this amino acid and the NH of the other amino acid, they should be present together. I'm making it like this, NH2, and then you will have the same kind of a structure, which is CH. You have got R over here, and there we have NH2. Now what I'll simply do is I'm just going to remove water from here. So you simply remove water, and then the bond will be formed between these two alpha amino acid, and this kind of a bond, students, is nothing but a peptide linkage. So we are done with this question as well. Moving on to the next question. The next question, everyone, is a derivation which you all must have seen in your books as well. I'm pretty sure you must have practiced it a lot. So let's not get to the entire derivation. I'll just tell you what you were supposed to derive. Derive an expression to calculate the molar mass of non-volatile solute by osmotic pressure measurement. And if I have to find this expression, let us figure out what derivation we are supposed to do here. The derivation that we were supposed to do here was WRT. I hope you are getting it. WRT upon, since we are talking about osmotic pressure, pi V. So this was the derivation that you were supposed to derive. I'm pretty sure you must have done it right. Moving ahead to the next question, everyone. The next question is, explain monodentate and ambidentate ligands. Alright, let's begin with this first, monodentate, and also you were supposed to give examples. So let's start with the first one, which is monodentate ligand. Mono means one, dentate means denticity, that means the number of bonds it is going to form. So when I say monodentate ligands, the best example could be ammonia, right? So ammonia, since it has one lone pair, it will form one coordinate bond, so it's a monodentate ligand. Likewise, all the halogens are monodentate ligands. We have so many examples of monodentate ligands that we must have done in the chapter coordination compounds. Then what about ambidentate ligands, everyone? Ambidentate ligands are those which contains two or more donor atoms, but only one will participate at a time. So if I have to write the example of ambidentate ligand, the example could be Cn minus. Here there are two donor atoms. Carbon is also the donor atom, nitrogen is also the donor atom, but they cannot participate together. The question is why? The answer is very simple. See, they cannot participate together, the reason being, if you actually take both of them, and let's say this is also making a coordinate bond and this is also making a coordinate bond with a single metal, then it will result in the formation of a three-membered ring, and if you remember, a three-membered ring is just not stable. So that was the reason why we actually spoke about the ambidentate ligands. Ambidentate ligands are those which has two or more donor atoms, but at a time only one can participate. And the best example could be Cn minus. Now let's come to the nomenclature part, because when you're writing the example, you need to write the names, that what happens when carbon is participating, what happens when nitrogen is participating. When carbon participates, then the name is cyno, whereas when nitrogen participates, the name becomes isocyano. There are just three examples of ambidentate ligands that we have. One is Cn minus, one is NO2 minus, where N can participate, the name is nitro. If O participates, that too with a negative charge, the name becomes nitrito. And then we have SCN minus, where if S participates, it's thiocyanato, whereas when N participates, the answer will be isothiocyanato. So that's our question number 8 with the explanation of monodentate as well as ambidentate ligands. Okay. Let's take the next question, students. The next question is, explain the trends explain the trends in the following atomic properties of group 16 elements. The first one is atomic radius, the second one is ionization enthalpy, okay, and the third one is electronegativity, and the last one that we have is electron gain enthalpy. This was the easiest question from P block that you could expect. Group 16, first of all, what are the elements of group 16? Oxygen, sulfur, selenium, tellurium, polonium. Now when I talk about the atomic radius, the answer is quite simple. As you go down the group, the atomic radius will increase definitely because the number of shells are increasing. With that, the nuclear force of attraction is decreasing and the shielding effect is also increasing. That's the first property. The second one is ionization enthalpy. What is ionization enthalpy? Ionization enthalpy is the minimum amount of energy which is required to remove the most loosely bound electron from the outermost shell of an isolated gaseous atom in its ground state. So, in simple terms, nothing but the energy required to remove the last electron, that's it. So, when I talk about ionization enthalpy, isn't it directly connected to the atomic radius? Now, as you go down the group, the atomic radius is increasing, which means it will be easier for me to actually remove the electron from the last atom because the size is too huge and the nuclear force of attraction is going to be very, very weak. So, I can simply remove the electron from the last atom. But if I talk about the first one, the size is very small, and if I try to remove the electron from that atom, it is going to take a lot of energy. So, when it comes to ionization enthalpy or ionization potential or ionization energy, down the group it will decrease. Moving on, electronegativity. Now, what is electronegativity? This is a very, very important part because this has an exception in group 16. See, the elements of group 16, oxygen, sulfur, selenium, tellurium and polonium. So, this has the exception part. Third is quite normal. Fine, let's talk about the third one still, electronegativity. What is electronegativity? Electronegativity, students, is the tendency of an atom to attract the shared pair of electron towards itself. They are both sharing, but this will have more power to attract the shared pair of electron towards itself. So, let's start with electronegativity. Obviously, it depends upon the size. The size of oxygen is going to be very small. You move down the group, the size will increase. So, the one which is having smaller size will have high nuclear force of attraction, and that high nuclear force of attraction will cause nothing but the attraction of electron more towards itself, and that is your electronegativity. So, oxygen will have highest electronegativity, and as you are going down the group, the electronegativity will decrease. Fine. Moving on to the next one, electron gain enthalpy, which I said it has an exception. I just want you to think about it for a minute while I'll drink some water. Alright, so you had enough time to think. Let's start again. And we were talking about electron gain enthalpy. Now, what is electron gain enthalpy? The tendency of an atom to gain electron, right? Simple. But if I ask you about the electron gain enthalpy from group 16 elements, the elements of group 16, oxygen, sulfur, selenium, tellurium and polonium. Now, let's get to the concept, electron gain power. We all always think that because oxygen is having smallest size, its electron gain enthalpy is going to be maximum, which means it can easily gain electron. But the answer is, the highest electron gaining power, students, is of sulfur and not of oxygen. So, sulfur will have higher electron gain enthalpy and not oxygen. Now, why so? The reason is simple. See, when I talk about sulfur, see, undoubtedly the size of sulfur is bigger than that of oxygen. There is no doubt about it. The question here is which one will gain the electron. When it comes to oxygen, students, I will just take oxygen here, which is 1s2, 2s2, 2p4, and after oxygen oxygen, the next element in the group is sulfur. A group is called as a family. It is because their outermost electronic configurations are same. So if oxygen ends with 2s2, 2p4, definitely sulfur will end with 3s2, 3p4. Right? So now think about this. In case of oxygen, there are two shells. Let's say this is oxygen, the nucleus, first shell, second shell, sulfur, nucleus, first shell, second shell, and the third shell. Sorry. So now when it comes to gaining of electron, definitely oxygen will attract it more, very strongly. The size is small, force of attraction is powerful. So electrons definitely will be attracted. But the problem is that already in the second shell there are 4 plus 2, 6 electrons existing. That plus the size of second shell is definitely very small. So what happens is the incoming electron obviously is attracted more because of more electronegativity, but when it comes to addition, the already existing 6 electrons will repel the incoming electron, and because of that the addition will become difficult. So yes, when it comes to electronegativity, oxygen will rule, but when it comes to electron gain enthalpy, sulfur will rule. Again, I still agree to the fact that sulfur will have less power to attract, but when it comes to addition, the addition will be easy. The reason being the last shell is third shell, which is bigger in size in comparison to the second shell. So there actually is space for the new electron to come, get added, and therefore when it comes to electron gain enthalpy, it will be sulfur dominating, then oxygen, and then the remaining elements, right? So this was your question number 9, students, from section B. I hope it is pretty much clear till here. I'll end the session here today, and the remaining part of the session we'll do on Monday at 4 p.m. The remaining question paper, I'll give you the solution then. Meanwhile, if you have any further doubts, you can just note that down, keep the question paper with you, so that when I'm telling you, you can just check the answers. But please do not panic, don't take stress. We have many more to go. Don't worry about it. I hope you did well, and I hope you're going to do further well in your upcoming exams. Alright, so we are done for the day. Thank you all so much. Thank you.